Hello students, today we will be discussing isotopes for grade 9 chemistry. This is a part of the atomic structure chapter. Let us look at these two atoms of chlorine, the one on the left and the one on the right. What is the difference between these two? If you have studied the atomic structure in the previous lecture, you will know how to find out the proton number, the electron number, as well as the neutron number. The proton number is represented by that number 17 on the lower left subscript on both of these atoms. The electron number is again same for all atoms. The neutron number, however, would be the result of subtracting 17 from 35 for the one on the left and 17 from 37 for the one on the right, which ends up in the neutron number 18 for the atom of chlorine on the left side and the neutron number 20 for the atom on the right side. So what is the difference between these two atoms? The proton number and electron number are identical. The only thing different in both of these atoms is the neutron number. Let's look at another example. If you were to look at different kinds of hydrogen atoms present in this presentation, the first one being called protium, deuterium, and the third one tritium, you'll notice that all of these atoms contain one proton and one electron as represented by the key. However, protium has absolutely no neutrons, deuterium has one neutron, and tritium on the other hand has two neutrons. What do these examples tell us? That isotopes are atoms of the same element with the same number of protons and electrons but different number of neutrons. As a result, they have the same proton number but different mass numbers. Most elements occur as a mixture of isotopes naturally, except for a few. Now, you must be wondering that this must have some impact on the chemical and physical properties of these atoms. Because chemical properties are dependent on electrons solely, which are consistent in all of the isotopes, the chemical properties have no impact through the difference of isotopes. For example, chlorine 35 and chlorine 37 both react with sodium to produce sodium chloride. However, due to a change in the number of neutrons, the mass of the atom is affected, which in turn leads to different physical properties in different isotopes. For example, hydrogen with 2 neutrons has a slightly higher boiling point than hydrogen with 1 neutron. There are different uses of different isotopes, and I have listed some of them down for you to know. For example, radioactive iodine is used in the treatment of thyroid disorder. Iodine 123 is used to scan the brain. Carbon 14, on the other hand, can be used to estimate the age of things that contain carbon, as well as to trace the path of carbon in photosynthesis. Cobalt 60 is used to irradiate cancer cells.